In this video, we will learn about the state design pattern and how to implement it using C++ code. State is a behavioral design pattern that allows an object to perform different actions based on its state, appearing as though the object changed its class. If you've ever created an AI for a video game using a finite state machine, you have already used the state pattern. An enemy may be able to patrol, attack, and flee. When a certain set of conditions is met, its state gets changed, and it performs the appropriate behavior based on the state that it's in. Let's look at an example of how we can implement the state design pattern using C++ code. First, we will declare a class named context. Then we will create a class named state, inside of which there is a protected pointer to a context named context. Next, we will use the public access modifier. We will add a virtual destructor to this class. Then we will create a function with a void return type named setContext, which takes in one parameter, a pointer to a context named context. Inside of here, we will set the context member variable equal to the context passed into this function. Next, we will have two purely virtual functions with a void return type, named handle1 and handle2 respectively. After that, we will create a class named context that contains a private pointer to a state named state. Then we will use the public access modifier and add a constructor for our context class that takes in a pointer to a state named state. Inside of this function, we will call this class's transition2 function and pass in state. Note that we have not yet written the transition2 function, but will do so momentarily. Next, we will add a destructor for this class, inside of which we will delete state. Then we'll create a function with a void return type named transition2, which takes in a pointer to a state named state. If this class's state is not equal to a null pointer, we will delete it. Then we will set the state of this class to the state passed in as a parameter to this function, and then call the setContext function for the state, and pass in this. After that, we will create a function with a void return type named request1, inside of which we will call the state's handle1 function. Then we will have another function with a void return type named request2, inside of which we will call the state's handle2 function. Next, we will create a class named state1 that extends the state class with a public accessibility. Inside of this class, we will use the public access modifier and override the handle1 function and the handle2 function. Inside of the handle2 function, we will output the string state1 handles request2, and then a new line to the console. Then we will create a class named state2 that extends the state class with public accessibility. We will use the public keyword and override the handle1 function. Inside of here, we will output the string state2 handles request1 and then a new line to the console. After that, we will override the handle2 function, and inside of here we will output the string state2 handles request2 and then state2 change the state of the context to the console with a new line output after each string. Then we will call this class's context's transition2 function and pass in a new state1. Next, we will define state1's handle1 function. After line 47, let's make sure we put a semicolon and not a pair of opening and closing curly braces, which will output the string state1 handles request1, then a new line, then state1 has changed the state of the context, and then a new line to the console. After that, we will call state1's context's transition2 function and pass in a new state2. Time to test our code. Inside of C++'s main function, we will create a pointer to a context named context that we set equal to a context with a new state1 passed in. Then we will call the context's request1 function, and then the context's request2 function. Finally, we will delete the context. On line 25, we need to make sure that we use an arrow and not a dot, since the this keyword is referencing a pointer. When we run the code, notice that state1 handled request1, then state1 changed the state of the context to state2, then state2 handled request2, and then state2 changed the state of the context back to state1. We can use the state design pattern when we have an object in our program that needs to behave differently depending on its state, when a class has lots of conditional statements that alter its logic according to the values of the class's fields, and when we have a lot of duplicate code across similar states and transitions. Advantages of this design pattern are that the code for each state goes inside of separate classes, aligning with the single responsibility principle. We can introduce new states without changing existing state classes or the context class. And we can simplify the code by eliminating massive if-else checks in our code. The disadvantage of state is that it can be overkill if a state doesn't change frequently or only consists of a few states.